Hi, welcome back. This is Michael King to Time Value of Money Part 3, where we discuss annuities. We're going to talk about two types of annuities, an ordinary annuity and an annuity due, which are both discussed in section 5.4 of Booth, Cleary, and Rakita. So an annuity is an investment that pays out a fixed amount each period called the payment. And that payment could be coming at a monthly basis, a quarterly, or an annual. The key is that the amount is fixed. There's two types of annuities. One is called an ordinary annuity. And the key thing to know about an ordinary annuity is that you don't get your money until the end of the period. This is how a bond is set up or a mortgage payment. Okay, notice that you start today at point zero and you either receive your first bond payment at year one, or you make your mortgage payment at the end of the first year. This is called an ordinary annuity, and notice that the amount each year, in this case 5 years, is $1,000. It's fixed, so you have 5 payments of $1,000. The second type of annuity is called an annuity due, and this is maybe a confusing term, but notice that an annuity due, the payments are at the start of each period. And this is how we're going to be pricing leases, such as an auto lease. Okay? So if we start today making a payment on an auto lease, you actually make your first payment on the day zero. If you're making 5 payments, you would make it on day zero, on the first anniversary, the second, the third, and the fourth anniversary of a 5-year schedule. Okay? So in an ordinary annuity, payments come at the end of the year. Annuity due, payments come at the start of the year. So the formula for an ordinary annuity is shown here. A mathematician calculated how to do this in one step by looking at the payment, looking at the interest rate, and the number of periods in order to calculate the future value. Notice that the number of periods is n. The payment is $1,000 in this case, and we have an interest rate. Okay, so let's look at an example. Before we look at an example, let's just compare this to the formula for the future value of an annuity due. Remember that for an annuity due, payments are coming at the start of the period, not at the end of the period. Notice that the formula looks almost the same except for one difference. The difference is that we have to grow whatever we receive by 1 extra period. So we're going to add 1 plus the interest rate. This is going to be to cover up for that extra period, because effectively at the end of 5 years, the money will have been invested for 6 periods, because it's coming at the start of each period, each of those 5 payments. So that payment on year 0 actually gets invested all the way to year 5, which is going to be 1 extra period compared to the ordinary annuity. So let's take an example. What will an ordinary annuity be worth at the end of year 3? What will be its future value? If it pays $1,000 at the end of each year, and we have a 6% rate of interest. Okay, let's draw out the cash flows. Okay, we have 3 cash flows of $1,000 coming at the end of each period. Notice that the first cash flow is at the end of the first year, second at the end of the second year, and the third. That is the 3 cash flows. We want to know what this is going to be worth at the end of the third year. So you can see that the third payment comes on the maturity or the anniversary date of this ordinary annuity. That first $1,000 is going to be invested and compounded for 2 periods. So if you were to use your present value, future value, you would say the present value is $1,000, the future value is going to be $1,123, growing at an interest rate of 6% for 2 periods. That period at the end of year 2 is then going to grow for 1 period, and notice that it only accumulates $60 of interest. That's because It is 6% on $1,000 for one period. That final $1,000 doesn't grow at all because you receive it on the maturity date. So what is the future value going to be? You simply sum up those three cash flows, and in the future, the value of this ordinary annuity is $3,183.60. Now, if you didn't want to do this by hand, you could have used that formula. You simply have to put in the payment of $1,000, the interest rate is going to be 6%, number of periods is going to be 3, and you will get the same amount. We can reverse this formula and look for the present value of an ordinary annuity. What would it cost you today to buy this ordinary annuity if it pays out $1,000 at the end of each year at 6% per year for 3 years? Okay, so here's our cash flows. Notice that we get the $1,000 at the end of years 1, 2, and 3. Unlike the previous formula, however, we want to know what are they worth in today's dollars, not in future dollars. So we have to find the present value of the first $1,000. Notice that we can use our future value, present value formula. We're discounting this $1,000 at 6% for one period, or 1 year in this case. Notice that it's worth $943.40. In other words, if we took $943.40, invested it for 1 year at 6%, it would grow to be worth exactly $1,000 at the end of the year. The money we receive at the end of the second year is we would have to invest $890 today. And to get $1,000 at the end of 3 years, we would have to invest only $839.62. Take a look. Does this make sense? For the first period, we have to put the highest amount in because it will only accumulate interest for 1 year at 6%. For the second, it's going to be less because we're going to earn 2 years of interest and we're going to have compounding. Similarly, for the third payment, we're going to invest a smaller amount because it's going to get 3 payments and it's going to compound over those 3 years. Okay, so the sum of those different present values is going to be $2,673.01. That is the present value of this ordinary annuity. Again, you just have to know the formula. You plug in your payment of $1,000, your interest rate K of 6%, or your discount rate, 3 periods, and you will get this. Let's look at an ordinary annuity and now let's look at a future value of an ordinary annuity where we want to generate a value in the future of $3,183.60. Okay, this is the same one we've been using, so I can go over it relatively quickly. Okay, we know that we want to have $1,000. We know that we want to receive equal payments in each period such that their future value is going to be $3,183. We know that if we plug it into the formula using the 6% rate of interest, the equal payment is going to be $1,000 at the end of years 1, 2, and 3. So you can see that with this formula, as with the present value, future value formula, it's just a question of solving for the unknown. You have to have the other inputs though. Now let's look at an annuity due. Remember, the annuity due, the payment comes at the start of the period, not the end. So we're going to have to modify those future value and present value formulas. Why? Because there's going to be an extra period of interest when calculating the future value, and there's going to be one less period of interest when calculating the present value. So here is how we modify the future value of an annuity to get an annuity due, and here is how we modify the present value for an annuity due. Do you see the difference? In each case, we're correcting by adding a term at the end. We're adding 1 plus k. Okay, so this is going to adjust from an ordinary annuity to an annuity due. Okay, so a few quick examples. Let's calculate the future value of an annuity due. Again, $1,000 invested at 6% for 3 years. Okay, notice that the timing, however, starts immediately, day 0, and the final payment is made at the start of at the end of year 2 and the start of year 3. As a result, that first $1,000 actually grows for 3 periods. It's going to grow at 6% and be worth $1,191. That second payment grows for 2 periods and compounds interest. It's going to be worth $1,123. That final payment compounds for 1 year at 6%. You guessed it, $1,060. Adding up those 3 cash flows, we get that they're equal to 3,374.62. Plugging it into the formula, noticing that we have that 1 plus k at the end, we can see that we get this correct amount. For the present value of an annuity due, same thing. Draw our cash flows, our timeline, our cash flows, find the present value of each one. Notice that the $1,000 is already expressed in present value terms, the very first payment. It starts at the start of the period. Add them up, $2,833. Putting them into the formula, being sure to add that 1 plus k, we get the correct amount. Okay, so remember, when using an annuity due, you have to make an adjustment to both the future value and the present value for the fact that the timing of the cash flows is different. It comes at the start of the period, not the end of the period.